So we don't want to go the traditional route of I have a problem, then a corporate team of data scientists, data engineers are sitting there waiting for me on the front line to pass them the problem. Then they work with their data engineers to get the data and run their machine learning and AI, and then they deploy it. This route is not cutting it. And this is not the way to solve the problem. Rather, we want people who understand their process, the SMEs, to do the analytics and ask the questions they want. So, agentic AI for manufacturing analytics is nothing but a human level automation, right? So, you have a complex problem you want to solve. You would divide it into sub problems. Right, you get pieces of software that are really, really good at tackling those fragments of the problem. And then you have an orchestrator that actually, makes sure that all of those little, pieces of software agents work towards achieving that goal, right?
Welcome to the AI in Manufacturing podcast here on Industry Forward TV. I'm your host, Kudzai Manditereza, and today I'm joined by Yousef Mohassab. Yousef, thank you so much for joining us on the show today. Welcome.
Thank you, Kudzai. Very excited.
Awesome stuff. So, before we begin, can you introduce yourself to our audience?
Absolutely. So I'm Yousef Mohassab, CEO and co-founder of Facilis AI. Previously, I was an executive at Coke Industries for one of their major manufacturing companies. I was leading their analytics department. It was basically the department in charge of, data acquisition from all the plants, building machine learning AI, deploying it at scale. Had an amazing team. Enjoyed my almost 5 years there. Solving nice, interesting, complex manufacturing analytics problems before I moved to Facilis.
So as you mentioned, over the past few years, we've really seen manufacturers kind of like really experimenting, or rather kind of like looking at how best they could leverage artificial intelligence to transform their operations. And lately, agentic AI has been gaining quite some significant amount of attention. So, could you sort of like give us an overview of how you see agentic
Yeah.
AI potentially transforming the landscape of manufacturing operations?
I think so. Manufacturing analytics is dear and close to my heart. It has been my career after grad school, right? And I would say we've been always catching up, playing catch up in terms of tech. So tech is always built in Silicon Valley where I am, and by tech companies, amazing solutions that work likely for other industries, and then by the way they expand to our vertical. And most of the times you get something, but you never get what you wanted to get. So we really wanted to build something by manufacturers and people who understand the domain problems, and such that the acceptance from the end users would be much higher. They would be relating to the product. So agentic AI, I mean, when we started building our product, the term agentic AI was not in existence at that time. So it was coined afterwards. So we built a product. We wanted to build a flexible, expandable product that helps manufacturers turn raw data of any sort, any type, if it's numerical, text, image, video, audio, you name it, um, turn those raw types of data from any source, so it has to be source agnostic, into actionable insights. And the trick is we want this to happen in minutes, if not seconds, right? So we don't want to go the traditional route of I have a problem, then a corporate team of data scientists, data engineers are sitting there waiting for me on the front line to pass them the problem. Then they work with their data engineers to get the data and run their machine learning and AI, and then they deploy it. This route is not cutting it, and this is not the way to solve the problem. Rather, we want people who understand their process, the SMEs, to do the analytics and ask the questions they want. So that was basically that background I gave you is sort of like the pain point, the origin of, you know, multi-client. That was the name that we gave it initially. So we wanted to write, you know, pieces of software that can communicate and work together in harmony to achieve a task, but it's a complex task. Then, you know, agentic AI kicked in. Awesome. Everybody's familiar with what that is, but I'll give a clear definition, at least according to how I see it. So, agentic AI for manufacturing analytics is nothing but a human level automation, right? So, you have a complex problem you want to solve. You would divide it into sub problems, right? You get pieces of software that are really, really good at, you know, tackling those fragments of the problem. And then you have an orchestrator that actually, you know, makes sure that all of those little, you know, pieces of software agents work towards achieving that goal, right? A great use case. I'll give that use case to just illustrate what I mean
Yeah.
and show the difference between classical machine learning and agentic AI approach. Typically, when we, you know, everybody in tons of industries would have some sort of a quality system that monitors the output of a process, whether it's cameras or you know, some metric or chemical analysis or whatever that is, that tells him that this is how much, you know, how good you're doing with your process or throughput or yield metric or whatever that is, right? So if you take the that quality metric and you're monitoring it over time, a lot of times, you know, it's a very common use case that people wanted to monitor when things go wrong. Like you're not hitting your metric, you're below your metric, right? So traditionally, we would deploy a model that predicts or it monitors, right, real time, that KPI, right? And when it decreases or it increases, you get alerted, right? Likely, if it's a quality metric, if it increases, that's nice. You're actually doing well. But it alerts you typically when it actually crosses a lower threshold, right? That has been the case. Everybody's solving it this way. You can take that example that I said on quality and then apply it to vibration analytics, whatever that is. Anything that is changing in time, right?
Yeah.
And you as an end user, process engineer, you know, automation engineer, you know, operator, technician on the floor, you get notified to make a data-driven decision at the end. Something has gone wrong, go fix it, right? Up until now, that's classical. That's, you know, how it works. I get notified 2 a.m. This is what is happening. Go figure out what has gone wrong in the process. Now, when we deploy this, which is an actual active use case that is deployed for one of our customers, the quality monitoring, you know, multi-agentic solution, you will get the monitoring piece that happens real time. And it's not a classical machine learning model. It's a self-adaptive that learns, you know, real time, right? So that's a big difference, right? It's not a batch machine learning model that you take some historical data, you train it, and it understands the you know, from your historical pattern or patterns, and then it predicts, given that the future is going to be similar to the past. Well, what if the future changes? Like your process variables, you're now in a different operational space. You've upgraded certain equipment, you did some major changes in the hardware of the process, right? So you're no longer in the you know, in the past.
Yes.
operational space. Now you're in a newer operational space. You know that classical machine learning is going to be, the model is going to drift, and it's not going to give you the good results that you wish for and that you used to get when you trained the model, right? So
Yeah.
our agent that actually does the more active monitoring, which is one of the many agents that I will mention now, it uses online learning. So it learns, and it establishes new baselines automatically. I don't have to interfere and intervene to actually teach it. So the machine itself is learning. That's one piece. The other agent that we have is an agent that understands your process. In our solution, our Quanta platform made by Facilis, we out of the box give as we speak about 23 specialized agents that understand about 15 different industries across continuous manufacturing and discrete manufacturing. So we'll give you this out of the box, right, that understands your process. And then we make it smarter when we add your standard operating procedures, manuals, you name it, your internal domain knowledge, right?
Yeah.
We let it access those effectively. So you have that agent. And then you have definitely an orchestrator agent, a critique that understands the flow and what is going on with the two agents. So when you get a drift, it detects, like, for example, your quality has gone, below a specific threshold. It will, work coordinated, coordinating with the domain SME, that agent that we have, we call it domain SME, to get to some mitigation plan if it knows that, either from our basic agent or from your own documents. When you have an SOP that states, when this change happens, here are the actions that you need to take, right?
Yes.
And it will simply send you that 2 a.m. email still, or text telling you, Kudzai, this is what is happening, that your metric has changed it in a bad way that you
Yeah.
don't like. Your quality has dropped, or whatever metric that you set. And here are the actions that we recommend you should take. But that piece that I mentioned is not just from the domain, because what action do I need to know? I know that something has gone wrong. If I don't have an SOP that explains to me what to do, then what would I do? In our active deployment right now, the example that I gave you, we access the relevant upstream process variables. We have a number of other agents that do machine learning, and they look at correlations, they look at a bunch of them also do optimization, find the optimal range and whatnot. And they will tell you, here are the variables that have changed in the past, that we think have changed from the past when it was good, and we recommend that you should put them back to this range.
Yeah.
And now I'm moving from just an insight, and then the left is to the human to figure out. In a multi-dimensional problem, we know what manufacturing is. You can go bang your head against the wall for like weeks trying to figure out what has changed, what has led to that change downstream. And you're trying to run, give me that, a little bit of data from here, a little bit of data from there, and then you're trying to glue it and then run it in Excel, or run it in Minitab, or whatever
Yeah.
statistical package that you have access to. Given that you're a data savvy person, you wanted to get to the root cause of the problem.
Yeah.
And then we deliver those actionable insights to you at the end that you can act upon, right? Are they 100% accurate? In certain cases, they're very accurate. Yes, they're of high accuracy. In other cases, they 70, 80%, sometimes 60%. But guess what? They get you much closer to an actionable insight than ever before. So in minutes or seconds, I'm getting very, very close to an actionable insight that I can use and act upon, as opposed to the traditional route. And there are other use cases I'll
Yeah.
shed some light on.
Oh, yeah, absolutely. Yeah, no, we're going to touch on the implications of accuracy or lack thereof in a bit. For now, I just want us to kind of like step back a bit, to kind of like really hone in on the value proposition or the agency of adoption of agentic AI, as it were. Because first of all, I 100% agree with you that having a central data science team quickly becomes a bottleneck, right, for addressing all of your AI use cases, right? Sometimes it may take weeks, months, just to kind of like get the insight that you may need. Now, and you also mentioned the fact that manufacturers have always been looking for analytics or ways, and we just been playing catch up. So my question here is, what's different now, or what is it that is so urgent, or what's the value proposition that would make manufacturers want to really consider this type of technology? Yeah,
Yes.
feel free to explore to
So
that.
very good question. Two things. I mean, I myself had a big team and I was doing manufacturing analytics. That has been my career, right?
Yeah.
So I'm reflecting on my own pain points. So I was really trying to get to, uh, um, you know, get to solution as quickly as possible. That's what really everybody wants, right? And everybody wants. So if you ask me two constants, that's what I internally at Facilis, that's what we always say, and I try to stick to that message. I don't think that any manufacturer anywhere in the world, in any industry, will wake up in the morning, come to me and say, hey, give me a solution that really gives me insights, probably in days, weeks later when I have a problem. Or give me a solution that requires an army of resources, data scientists, data engineers, IT folks, because I don't have work for them. So give me a solution that is daunting, right? Nobody wants that. So those are the two constants that I believe will stay with us for so long, right? They're not going to change. The first one, they really wanted, and everybody who works on the front line, from the ground and up, right, from the floor and up, they, when they have a problem, they want to access the billions and trillions of data points that they're collecting from their sensors that are being historized. And we've been really good at this in manufacturing over the past decade. Data has been growing exponentially. IoT sensors are becoming cheaper, effective to deploy more than any time before. But we're very good at this data acquisition. We store it somewhere in a historian somewhere, whatever type of historian we have, and then we tap into a fraction of a percent of it. So people want to get to that data as quickly as possible. And you've got a lot of very smart people who understand their processes very well. Those are the SMEs that we have, right? They went to chemical engineering programs, they went to mechanical, industrial, electrical, to become experts in their domains. They're not data scientists. They will not be data scientists. You can teach them certain skills, yes, but they're not going to write code, and that's not their competitive advantage, right? And they're sitting there with a big barrier between them and the tons of data that they're collecting, and they're still doing it the old ways that we've been doing, right, for decades, right? You get like a snapshot of the data, a very tiny bit, if you can, from the historian, and then you work your way with a bunch of assumptions. And a lot of times, unfortunately, we make decisions on the front line. So over 90% of our decisions are made based on either previous experiences or the most senior guy that we know who trained us that we can call him, right? And a lot of times even it's gut feeling driven because they need to make a faster decision. They can't wait. Yes, if you have a data scientist, for those companies that do have them, this is not to bash data scientists. They're amazing. I mean, my team, I built a team from the ground up that was mainly centered around data scientists. But the problem is, these guys, they need to make a decision right now, because else they're wasting tens of thousands of dollars, right, in their shift. So they wanted to do something, do something about it. So what they end up doing is, okay, I'll fire a request to the corporate capability or the data scientist sitting next to me, and he's gonna do his thing, but he needs time to do that. He doesn't have the tools that allow him to really tap into data very quickly and then turn them into insights. It'll take him a while. I mean, a correlation exercise, a very simple one, right? typically would take you, a few hours. Somebody needs to come in, understand what the data that you're asking about, and then they go pull the data from those sensors, from wherever the historian is, and then they run their analytics, their correlation, algo, and then come back with the findings, right? And still, it's partial findings because that's basically just statistics, right? So that barrier between the decision makers and people who understand their process and the data, this is number one value proposition. You're basically removing that. You're allowing those who folks who understand their process to access the data whenever they need to access it, and run cutting edge algorithms and machine learning and AI, fancy AI that is floating around, but you're now putting it to use. They can access it without having to spell the word algorithm. They just ask the question they want to ask, and off you go. They get the insight they need, and they can visualize, build their visuals in seconds that they desire, right? So that's number one. Number two, the platform itself. If you offer me a platform that is, in my past life, I was seeking something like this, to be frank. Something that really is the equivalent of a data engineer plus a data scientist plus an ML ops engineer plus an SME, right? All in one platform at the fingertips of every single user that I have in my team. I would never say no to something like this, right?
Yeah.
So, that in itself can save a mid-sized manufacturer the platform with those 4 FTEs, can save you at least over $3 million a year in just FTEs, let alone efficiencies and improvements in the process, right? So time to solution, time to insight that leads to solution. We cut that down dramatically from weeks, if you're super lucky and you have a team, to minutes and seconds, right? And then second, the amount of FTEs that we reduce. You're going to get those 4 FTEs available to every single user. So our platform is open to everybody in the organization to use, right? Sounds too good to be true, but I can get into the details to prove that it is what we're doing right now.
Oh yeah, absolutely. We're going to dive into the details shortly. You have already done a good job of kind of like painting a picture of what the use cases of agentic AI look like in manufacturing. And even just when I think about the possible applications, they seem endless. So for just to kind of like give direction to manufacturing leaders who may be thinking about this, what are the what would you say is kind of like the lowest hanging fruit, or what are the most common use cases when it comes to the application of agentic AI?
Very, very. So I think, another excellent question, Kudzai. Thank you for that. So we're solving the pressing problems that everybody is trying to solve in the manufacturing from a customer perspective and vendor's perspective. We're chasing throughput, yield, energy efficiency, predictive maintenance. What is unique about us is the approach that we take. We're trying to take that approach of, for God's sake, don't give me a platform that is a playground for data scientists. That's something that we're very clear from day one that we're trying to really, really not do. The other thing that we're trying to not do is, do not give me a rigid platform that I have to wait for a year to add a new algorithm or to add a new use case to solve, right? So don't do that, because that's basically, if you really map the landscape, and I was cutting checks for most of the companies that are well known and startups in this space that we have benchmarked over the past years. And again, this is not to bash anyone, but honestly speaking, you can simply divide the vendors into two big buckets. The third one is the consulting, firms and whatnot that come in with armies of resources, but those are not faster than my own internal team. So I wouldn't really touch them, right? So you have two big buckets. One, folks who give you, hey, build, they call it, self-service platform. But honestly speaking, it's just drag and drop to build a machine learning model. Like, okay, my folks on the front line, even if they understand something about machine learning, but they're not experts to fine tune a model, or even if you're automating that, they don't know where to use XGBoost, where to use deep learning, where to use, tree-based models. What is the value? I'm just wasting their time. I need to train them, coach them to get part of the insight, by the way. I insist on that. So that playground for data scientists is very dominant. Again, it's driven by other use cases, other verticals and other industries. The second bucket is folks who figured out that this is not the way. So AI, so manufacturers are not in the business of building AI. They want to use it. They were very clever, not nice. But what they did is they built a platform that just solves a single use case. Right? Oh, you have energy efficiency. I want to give you this solution. So a company is just built around that. You want to find the optimal ranges, like for your set points. I'll build a product that does that. The problem with the first one is clear. I still need data scientists to actually do this, and it's incomplete product. It doesn't help, and people just lose trust in it. And I can shed some light why that happened in the past for us. The second bucket, I need to stack up seven different platforms for folks on the, in manufacturing to use whenever they have a problem, depending on the use case. Honestly speaking, people just tend to use HMIs. That's what they're used to. And then when they turn away from that, they have something like, probably a centralized dashboarding system, Pi, for example. And that's it. If you keep asking them to bookmark tools upon tools, they're not going to use them. Then it ended up, being like, oh, another tool that's coming our way, right? So you need something really, expandable, flexible, expandable, and move away from build models, for God's sake. Build a solution. So give me something that helps me build a solution. So what we actually built that we think is dramatically different is we have that multi-agentic framework that I explained. Right now we're building those multi-agents, but in the coming months, we're actually going to open this up to our customers to build and customize those multi-agents. But if you look under the hood, you'll see, Kudzai, that's the thing that we believe we're really good at. And it's a big differentiator, is the fact that you're outcome driven. So for example, if you want an optimization, solve an optimization problem, I'm not going to bother you by, okay, this agent does have this linear program, this agent has this algorithm. No, it's okay, you just explain the problem that you have, and then here you go. You have an optimization agent that is automatically picking the right algorithm for you in the backend. You don't have to even mention the word algorithm. And then, do you need domain knowledge? So if it's a combustion problem, there is a router that picks the combustion agent that understands combustion. If it's like, pulp and paper, and you're talking about, mills and whatnot, it will pick that right agent for you. But at the end, you're really getting, the mix and match that you're building as an SME is understandable to you. It's not actually driven by the AI underneath or the machine learning. It's actually driven by the business outcome that you want it to get to, if that makes sense. And then you can build those, and then off you go. You have an entire solution that works. You can do your deep analysis, or you can deploy it in production, and it will be available at scale to everyone in the organization. So
awesome stuff. So maybe let's kind of like take a dive into Facilis solution offering. I mean, you made reference to the Quanta platform. What are the components that make up Facilis solution? What's the architecture look like?
Happy to say that. To shed a ton of light on that. So we've Quanta pipelines. That's the underlying architecture that actually is in the business of connecting to the data sources. And then we have the Quanta core itself. So they come as one product. For the customer, it's just one product, right? We deploy Quanta pipelines for customers who do not have a centralized historian. So we have the ability to go straight to the PLCs and SCADAs, and even gateways for sensors directly to pull data from for customers who don't have an existing solution. Right? And our pipeline is super efficient. It's built with AI in mind and real-time analytics in mind. So it's super effective. You can do a ton of at scale analytics on whatever types of data you get from your sensors, right? But if the customer has something in place already, so they have historian of some sort, we actually tap into the historian, right? So that's Quanta pipeline piece. And then we have Quanta, the core. That's what we call that's actually the customer facing. And Quanta Pipelines actually has a nice UI for the OT team to actually go and manage the connectors and whatnot. And we have our own, integrators that we work with that can help them get off the ground very quickly. And we do have two, greenfield, customers that we're working with. They're building, factories on the plant, and we've been selected to provide the service. So in that case, we deploy the entire pipeline from Quanta pipeline and then Quanta core product. The core product, what I call core product, is actually the user facing piece of the product. You have two modes. All of it, again, comes pre-configured. You have the ad hoc mode, which is what I kind of like hinted to all the time, what I've been hinting to all the time, which is you have a problem, you go and then you kind of like try, to interrogate the data that you have available to you, and you try to get to the root cause and run your deeper analysis, right, for SME. But then there is the other mode, which is real-time monitoring. So I could easily, after the ad hoc piece is giving me satisfying answer, right? So I looked at, Knox, for example, troubleshooting, and now I'm very happy. I understand that this multi-agent is giving satisfying answer. I'm convinced it. I wanted now to deploy it in real time so that it does the monitoring automatically. It's just one click of a button, and then it goes live. Everybody in the organization will have access to it, and you can configure it to send notifications to anyone in the organization. And our notifications are definitely, again, they're action focused and action oriented. You'll never get something is increasing, something is decreasing. Well, fine, okay, I need to go back and then spend hours, probably my entire shift, trying to understand what led to that change. We try to get you close to that root cause of the problem, so that you can likely make a decision or take action, immediately. So, Quanta pipeline and Quanta, and we are data source agnostic. We can run on-prem on the process network where where you have your controls, or we can run in the customer private cloud. We don't sit outside the customer firewall. We do not move data. We don't call third-party APIs outside the boundaries of the customer firewall. So basically, we support air-gapped deployment. That's what we're all about. So that everything is yours. We basically configure our platform in 2 weeks, make sure everything runs, works, and then we're hands off, right? We access it whenever you have a problem you want us to remove in, but everything sits on the customer side.
Absolutely. I think Quanta pipelines, from the way you describe it really addresses a fundamental challenge in industrial data integration, as it were, that lack of sort of like integration of data across OT and IT, which I would argue is still the biggest challenge that
Yeah.
manufacturers face today. So I want to kind of like peel into how Facilis sort of like approaches those data integration challenges. So you mentioned that you kind of like connect to historian. So maybe from a perspective of data source, sort of like data acquisition? Do you sort of like support standard connectivity interfaces? How
Yes.
how how do you
Yes.
approach?
So absolutely out of the box, we support all standard, connectors in the industry. So if UPC, UPCA's, DAs, sometimes, there are legacy systems, so you need to custom the connector, and this is where our integrators, come in. Amazing experience. They have a massive team of, hundreds, scattered in 30 different countries. They're very, experienced engineers. They can come in and help expedite that. But a lot of times, when if you have like a centralized historian, it's just a matter of like in a couple of days, your data is flowing and you're seeing actually, real time analytics coming through, right? I don't want to also underestimate that a lot of, in many cases you have, you have to customize connectors, and what you thought works doesn't work. You spend some time, so we're pretty much no different, at
Yeah.
this point. But when we get to the point that when we get the connectors and now data is flowing into our pipeline, you'll see a huge difference, and I can shed some light on this very quickly. In our Quanta pipeline, it's one of the problems we had with existing historians, right? So we found out that from a big a historian vendor, right, where you can build your dashboards and whatnot, you can choke their analytics server by just running some very simple arithmetic operations.
Oh, wow.
Choke it, I mean it, choke it like it's dead, right? We have in our Quanta pipeline the ability to scale up, scale down, and we use memory efficient architecture, processor efficient architecture, and we can run heavy real time machine learning workloads without stressing the system at all, right? So this is what we really, one of the pieces that we're so proud of. So even when the data is in transit, we can do real-time analytics on it, and then the dashboard that is built is basically loaded with a lot of AI and machine learning results in the back end. It's not just the trends, right? And that's a big differentiator that we have. So
Okay, perfect. Yeah, I mean, so the other thing that I want to touch on here is you highlight on your website this sort of like idea of a hybrid AI architectural approach, and you have
yes,
also alluded to this idea of combining large language models with
yeah,
machine learning, and you can also speak about like fusing domain specific knowledge into your solutions. Could you talk to us more about that approach? How does it work, and
yeah,
why?
yeah. So hybrid to us is intentional. Like from day one, you know we are internally you know emphasizing the message that our vision is to solve the problem the easiest way for the customers, and expose the data and analytics algorithms to them so that they're usable and they can turn raw data of any type from any source, as I said, into actionable insights. So that's the problem that we want to solve. um, we're not driven by a specific technology and trying to force it in because it will look nice, right? You have a lot of companies that come in and they sprinkle AI on top of their solution. I don't need that. That doesn't convince me. I need you to solve a problem and show me why your approach is different, right? It's not about I'm using which technology, right? So who cares about that, right? So having said that, the architects and the team, when they're building, they are basically using the best available techniques and tools to solve the problem, whether that is classical statistical, approach, SPC, World War One technique, or it is cutting edge generative AI, use it as long as it solves the problem. But we're not saying like we're a Gen AI, so everything is Gen AI. That's not going to solve the problem. I'll give you an example. We're one of the very early companies that said no to LLM to write code, because I cannot go to a manufacturer and then have LLM write complex SQL queries and back that up. And I know the accuracy of it is, I mean, at most, if you're super duper lucky and you fine tune it, 95%. Well, that you think manufacturers are going to live with the fact that 5% error. They can ask, show me the temperature at this plant, and then they get it at another plant where they get a pressure tag instead of a temperature tag. That's not going to fly, right? So we don't do that. Like, we do not. I mean, there are certain other cases where we have very, very clear guardrails for the LLM to, you know, write a piece of code that we can execute, and we have complex architecture to make sure that this is a validated piece of code before we execute it and surface the output to the end user, right? So
Yeah.
we're we use explicit code, we use classical machine learning and statistical algorithms, we use deterministic optimization algorithms in the back end, we use explicit physics-based agents in the back end, and I can shed some light on that because they're extremely valuable. You cannot separate that from manufacturing, especially in process industry. And we use generative AI whenever it has an advantage. It creates some more value to the end user, right? We are one of the biggest differentiators that we have is the fact that we call it marriage. We marry physics and engineering with statistics and machine learning. And that's very intentional. We do not want to have correlations that are not causation. I can speak to that in a second. Happen in our actionable insights. If we're true and we're honest to ourselves and we wanted to give people actionable insights, then we have to make sure that they're like, it's like a human level, kind of close to a human insight. Like if I go to an expert and he looks at the problem from different angles, statistics, he runs some analysis, some machine learning, and then he knows some physics or chemistry of the process, some engineering concepts, and then he gives me a holistic I would say set of recommendations that are a mix of all of these that are coherent. To give you an example, and I have scars to prove this, and my team would know this watching this episode. A lot of times, correlation in machine learning, right? And causal inference is trying to tackle that problem, but correlation, which is very common, is a lot of times is not actually causational, right? You have the common example of a correlation between the ice cream consumption and shark attacks, right, in the summer. Is that actually a causality? No, it's just a correlation because people happen to be on beaches more in the summer, and then sharks tend to attack more because they're more humans are in their territories, right? But that doesn't mean that actually, and they happen to buy more ice cream because of the hot weather. So you see what I mean? And I can find a lot of useless correlations, and that happens a lot. So you can build on a combustion system, a very famous example that I like. You can tell me, you can find a correlation, and I can demonstrate this to you at a later time, that shows you the core flame temperature is increasing with NOx is actually decreasing with the core flame temperature increasing. So core flame temperature increasing and NOx is decreasing, right? If I said the opposite, which that's counter physics. And what are you talking about? I mean, it's the if you look at the rate equation, it's exponentially dependent on the temperature, right? So if you say this to an SME, a combustion expert, he'd be like, does your machine learning model say that? He would turn his back to you, and then, good luck to you as a data scientist in the manufacturing space, right? He wouldn't really take anything seriously. After that, he would question everything. What we're trying to do is we combine both physics. So when we're answering that question, even if the agent finds that correlation, he would highlight that correlation is actually contradicting what we know in the combustion domain, because he's talking to a combustion expert agent that would actually give him the right dependency on temperature. So you kind of like eliminate that friction. That's big. That is really really big. So you're not just you know you're not just relying on statistical results. You basically have the physics and the chemistry of the process cooked in. And on top of that, even some SOPs that would be amazing when you add all of this in. So the insights are, much closer to be executed on that as actions. Okay.
I mean, the good thing is you've got a background in manufacturing, so you understand the that the amount of sensitive data that is involved here as you kind of like build the solution. And some manufacturers may have concerns around security and
Yes.
compliance. How does Facilis ensure data privacy and compliance with your product?
Yeah, as I said, we're like, air gapped deployment. We're one of the very, very few AI companies that do not call any external APIs. We do not move your data outside your boundaries. It is basically under your own control. So we don't have, it runs on a VM or an actual, on-prem server that is under your complete control. You can be disconnected from the internet and it will continue to run. So there is no worry there, right? So as secure as you can get your own data inside the organization, our application will offer the same security, right? So no, we don't open ports. We don't really, the customer pretty much has full control over how to configure it and where to base it. If they want to install it in a DMZ, if they want to install it on the process network, it is under their control. It's a containerized solution that they get to deploy it wherever they want. And for certain customers that don't have the teams that actually set up the hardware and whatnot and allocate hardware, we can give them a box. And again, open box. They can see all the configurations. They can, get, you know, all the guardrails in place on that machine, and they're up and running. So again, that's by design. We do not want to move data to anywhere. In fact, you have a lot of, first off, we want to be close to the process, because we have an optimization agent that actually can optimize your set points. And that optimization agent can be configured to push to the controls software that you have. So you find new optimal set points. You can click and it will be pushed to your control software that you have, AspenTech or Rockwell Automation or whatever software that you have, or advanced process control that you have, or an in-house built one, whatever you have. So we need to be configured to run on the process network. So if you are configured to run on the process network, you have to be extremely I would say security cautious, right? So we don't really, again, open ports or communicate with our platform from outside. It's you can, if we were to communicate with our platform once it's deployed in production, we would ask the customer to actually give us those timed remote sessions. We can remote into the machine and do whatever support that they need, and then we're out of the machine after that. So
Well, now what I want us to do is to kind of like paint a picture for manufacturers on what that implementation roadmap of agentic AI with Facilis
yeah,
looks like. Could you outline kind of like the typical steps involved
yeah,
from
absolutely.
initial assessment to full deployment, and what timelines are we talking about?
Absolutely. So, Kudzi, the way we like to engage with the customer is everything that I said. I was on their side not so long ago, so I'm very, very skeptical. I like to test things. So we set a clearly scoped pilot. Like, here's a problem. Probably that could be for easier execution. Give me a snapshot of your data. I'll put it in the platform once we sign the NDA and take care of the legalities. and then we put it in our own instance, and we give you unlimited access for whatever timeline that makes sense, 2 weeks, 4 weeks, 6 weeks. We don't like it to extend more than that. We give you that, you test it, prove that the technology works on your own data. We have definitely our own demo that people can get their hands on the platform and test it, but it's a lot of times it might may not be relevant to their problems. So we do that pilot. It's a paid engagement for commitment, and that amount that they pay comes off of the full license. So we're not in the business of making money on those pilots, but we just need people to be really intentional in their engagement with the platform. Not to, okay, you have 6 weeks pilot and then nobody actually looks at it, and then end of the 6 weeks, somebody's actually dabbling with it. So we don't want this to happen. So we found that when people are paying, they're committed. So those 6 weeks are gonna, whatever, 2 to 6 weeks will give you a feeling of, what the platform can do to you, what are the next, 2 to 3 use cases where you can actually, tackle on your list. You convert into a paid subscription. It's annual subscription. We would definitely, in the pilot, we will try to understand where your data is, and get some idea on your architecture and whatnot. So if you have a historian where that is and whatnot, and give some proposal on where we can be deployed, right? And when we're in the full license agreement, it will typically takes us from, this is what we've been seeing, less than 2 weeks to configure the connectors if you have some form of history, and that really gathers most of your data in one place, right?
Yep.
If you don't have, we have the integrators that we work with. They'll come in and then try to expedite the connectors, because a lot of times, I mean, this is not uncommon in manufacturing. You have different legacy systems, different, not necessarily legacy, but you have different systems and interfaces and whatnot that you need to actually configure. You're talking about, some of them could be as quick as in a day or two, you're up and running. Others might take a little bit longer. But we'll hatch, a plan with the integrators, and you will see the progress on a weekly basis. The key differentiator is in the 2 week scenario, once the data is flowing into the platform, we found out that from our early customers that they could see, and that's what they're reporting, the ROI in weeks. And that's for us is exactly, it's in our mission. If you read, our mission is we help manufacturers turn AI into ROI in weeks, rather than the lengthy months. On average, it takes an AI project a good whopping 18 months to start seeing ROI on that project, whether you have an internal team or not have an internal team. Our product, we don't need much support, intensive support. We don't require the company to have internal data science or data engineer capability. So we got that covered. So we can come in, configure it, and then the product is theirs after that. The maintenance they need to give to the product as part of the contract, pretty minimal. A bunch of configurations. If you lose connectivity, what to do, how to troubleshoot, what are the fail-safe strategies we have, and that's about it. So nothing really daunting from an OT perspective. And it's at the end, the entire pipeline is an open box to them, and it's got a GUI that they can get in and edit and configure, and see monitor the servers and the VMs real time.
Awesome. I mean, these clear benefits that you really outlined here, and but in most cases there is always some form of obstacles involved there. So I want to get a sense on your interactions with customers. What do you see as kind of like the biggest challenges that manufacturers often need to overcome as they engage with you?
I think Connectivity definitely, if somebody's starting from the equipment level, it would take probably a little longer than 2 weeks to configure things, and that's being realistic. There's no magic stick, I mean, that anyone has, right? So if I tell you otherwise, then question what I'm saying, right?
Oh yes.
But it's not, I wouldn't say it's an obstacle. There is still an education, like it's a mutual partnership that you have to establish rather than a transactional relationship between us. And that's what I love to say. So we're going to, have some back and forth and educate the customers on what is the art of possible for them. And that has been proven to be very, very effective. But a lot of times it's like we don't know a clear use case yet, because we've been doing this and our team is seasoned in manufacturing analytics, with decades of experience in the space, we can see like, oh, you actually have a ton, but they may have not, framed those use cases where they can, monetize it. That's why even in our pilot, in our proposal, we try to state the ROI as much as possible in the proposal itself. Here's, what you're going to get out of this platform, right? In number of x's, so x numbers of, or folds of what you're going to pay for the license in the first year. And this is based on defining, 2 to 3, common use cases, right?
Yeah.
So
Um,
technically, yeah, we that kind of like mutual partnership has to be there, so that you can get, you know, to educate your customers and also learn about their problems as well, and really serve them the best way. And instead of them being driven by ChatGPT and thinking that that's AI, that happens a lot. It's very common. And or us not really knowing the low hanging fruits, the valuable use cases. So it's kind of like mutual, learning process. That's kind of like I think I wouldn't call it a challenge, but that's the art of success, I guess, in our engagements.
yeah, I guess to conclude our session here, I've got two questions for you. For first of all, for manufacturing leaders who are listening here and thinking about starting their journey with agentic AI and Facilis, what practical advice would you give them to ensure that they're set up for success? And then maybe as a follow-up to that question, can you kind of give us your view of where this is all headed? What's the future of agentic AI in manufacturing?
The first point, I would say always start with a problem in mind. Do not really follow shiny technologies, and even if we ourselves are in the AI,
Yeah.
and you might think that this is driven by the hype, but no, we actually, it wasn't driven by the hype. It was driven by solving the problem. So always start from a problem and then work the technology later. Like, okay, find who can help you fail fast. Let me put it this way, right? If I engage with a company that is asking me, um, for 6 weeks or at most, and I'm going to see results, um, this is more or less a low risk engagement. I would have to, if I'm stepping into this, I would have to trial, I would have to experiment, I would have to be open to that. But I need to fail fast. It can't be like an 18 months experiment. Nobody's gonna, nobody's gonna support that. So start from a problem, a clear problem that you have, that you think your data that you have, you have sensors, physical sensors that are generating tons of data, and you believe that it might improve your process in one way or the other. Don't worry about the technology, and leave this to people, to the vendors, right? And look for someone who can partner with you and, you know help you fail fast, see the results. Is this, do that hypothesis testing, is this what you thought? And then based on that learning, you can pivot fast, and then hopefully in, 2 quarters, you're going to settle on a good use case that is worth the investment, right? So that's number one. Number two, um, do not default the hiring. I've done this and I built a massive team that I'm so proud of. But in manufacturing, I don't think the solution to manufacturing analytics is by hiring a bunch of smart data scientists. retaining data scientists, manufacturing, and data engineers is not really that easy. That's not their space. They don't understand the domain easily. You cannot train them fast enough, so you might get frustrated, and they're expensive resources. So their lifespan is 2 to 3 years, and then they're going to look for a company here in Silicon Valley to join. That's their dream, and that's where they belong and where they fit. So look for, you know, true self-service platforms. This is not because I am in the space. That was my has been my message even in my previous role at my previous company. Look for platforms that can help you create impact fast enough, and people who are making decisions can actually use the state of the art tech, because that's when you can realize ROI. We do not realize ROI on AI projects in manufacturing by deploying fancy tools and gadgets to the plants. It's when people who are decision makers on the front line and up are using these tools to make data-driven decisions. That's how you realize the ROI, right? Um, so, so this is the first point. Second point, so that you mentioned, where I think I believe that agentic AI frameworks will evolve dramatically. I mean, they have been already. I mean, you're seeing a lot of amazing, crazy advances, and we're already implementing a ton of those with multimodal models and a lot of tech. We're going to be presenting in October on the digital transformation in the steel industry in Pittsburgh. We have a paper and a patent that we're going to submit on a multi-agent that actually can do steel and metal defect monitoring and analysis real time. That is um, self-learning, adaptive, and it understands the intrinsics, and it can describe the defects very effectively, and the accuracy of it is unprecedented because it self-corrects. So that's unseen, unheard of. I mean, I've been in this industry for close to 2 decades. It's not something that I'm familiar with. This is like really unheard of, right? And that opens doors wide open for tons of use cases that we've never been able to tackle in the past, right? And I believe that will continue, and we will see a ton of amazing implementations in manufacturing. And so AI, and instead of having a success rate of right now almost 15%, so 85% of AI projects, they end up staying stagnant at the POC pilot level, and a ton of them fail. You're going to see a huge increase from 15%. I hope we're going to be north, 60%, 70% success rate in manufacturing, because technology is really making that feasible, right? It's no longer driven the hard way, hiring and training, which doesn't work effectively, and so on and so forth. So that's what I'm convinced of.
Amazing stuff. Amazing stuff. Thank you so much for taking the time out today to come and share your insights with us and all about your technologies. So, we're going to provide links to all the relevant material that we discussed today and your socials, your website, and all the likes. Do you have any last words for our audience? Anything that we didn't touch on this session?
I guess that was, I enjoyed the questions and the points that you touched upon. Kudzai, this has been very, very interesting, and I think I don't have anything more to add. But stay tuned, and the space is evolving dramatically, and I would definitely encourage people to experiment and see for themselves. You don't have to believe what anyone says. Get your hands on it as quickly as possible. The use of AI, I guess the say goes, and everybody's familiar with that. People who use AI will replace people who don't use AI, and I truly believe in that. And it's time to really disrupt the manufacturing analytics with true self-service platforms that can help us get the most out of the tons of data that we're collecting. So I encourage everybody to experiment and go really aggressive, and explore the space. It is becoming a competitive advantage. People who use AI in general in their processes, they're going to be much more efficient, and they will solve problems much faster. They can create superior products with higher quality than those who choose to not to adopt these technologies. So
Awesome stuff. Again, thank you so much for taking the time to join us today here. That brings us to the end of the session.
my pleasure.
Thank you.